there is a planet so extreme that metal may fall from its sky. The world is called WASP 76. It is not a rocky planet like Earth. It is a giant gas planet, more like Jupiter, but it orbits so close to its star that a year there lasts only a tiny fraction of an Earth year. That closeness changes everything. It belongs to a class often called ultra-hot. Jupiter's worlds, large enough to hold thick atmospheres, but close enough to be reshaped by their stars. One side of WASP 76b is thought to face its star all the time. On that day side, the heat is so intense that iron can exist as vapor mixed into the atmosphere like an impossible kind of steam. Winds may carry that vapor toward the cooler night side. Their scientists think it could condense into droplets, meaning the planet may experience something that sounds fictional, iron rain, that does not mean astronauts are watching metal splash onto a solid surface. WASP 76b is a distant gas giant, and no spacecraft has been there. The idea comes from studying how starlight changes when the planet passes in front of its star. A thin portion of that light filters through the planet's atmosphere, carrying faint chemical fingerprints. What is known is already astonishing. This planet is real. Its orbit is extremely close. Its atmosphere appears to contain iron under extreme conditions. What remains uncertain is the exact weather pattern, how the winds move, where the iron condenses, and what the planet would truly look like up close. Why does it matter? Because WASP 76b reminds us that planets are not limited to the comfortable categories in our own solar system. Nature can build worlds where familiar materials behave in unfamiliar ways. The takeaway is simple on some planets. Even metal may become weather. And that leads to a deeper question. How can a planet become this extreme in the first place? To understand WASP 76b, imagine moving Jupiter almost impossibly close to the Sun. That is the basic idea behind an ultra-hot Jupiter. These are giant planets that orbit very near their stars. They are not hot because they are burning like stars. They are hot because they are being blasted by starlight. At close range, over and over, with very little distance to soften the energy. WASP 76b is also likely tidally locked. That means the same side faces the star all the time, much like the moon keeps one face turned toward Earth. But on this planet, the effect is far more dramatic. One hemisphere is a permanent furnace. The other is a permanent night. The strange part is the border between those regions. The atmosphere does not just sit still, it moves. Fierce winds can drag gases from the day side toward cooler areas. If iron is vaporized on the hot side, then carried into a colder region, it may condense in the same basic way. Water vapor forms rain clouds on Earth. But the comparison only goes so far. Earth's rain falls through a relatively mild atmosphere onto a solid surface. On WASP 76b, scientists are working with a giant deep alien atmosphere, fierce radiation and chemistry under conditions we cannot recreate easily in everyday experience. The evidence comes from spectroscopy reading the fingerprints left in starlight. During transit, some wavelengths are absorbed by atoms and molecules, high in the planet's atmosphere. Scientists then compare those fingerprints with models to understand what may be happening. So the iron rain idea is not a photograph. It is an interpretation of light physics and atmospheric models. That uncertainty is not a weakness. It is how distant world science works. WASP 76b matters because it turns weather into a cosmic laboratory. It shows that atmosphere, orbit, and heat can combine into something far stranger than anything happening on Earth. And once we accept that the universe of planets becomes much larger in imagination, WASP 76b is more than a weird planet. It is a warning against assuming our solar system is normal. For a long time, the planets closest to us shaped our expectations. Small rocky worlds sit nearer the Sun. Giant gas planets live farther out. Icy bodies wait in the dark beyond them. It feels orderly, almost like a rule book. Then exoplanets began breaking the rules. Astronomers found giant planets hugging their stars. They found worlds with strange densities, extreme temperatures and orbits, unlike anything in our own neighbourhood. WASP 76b belongs to that larger story. It is a gas giant in a place where our old intuition would not expect one to survive for long. One reason this matters is planet formation. A giant planet probably does not begin life comfortably parked against its star. Scientists think many close-in giants may have formed farther out, where colder material was available, then migrated inward through gravitational interactions with the disk of gas and dust around a young star or with other planets. The details can differ from system to system, and they are still studied. That means an exoplanet is not just a world. It is a fossil of motion. Its current orbit may preserve hints of a violent past. WASP 76b also reminds us to be careful with the word habitable. Most planets we study will not be Earth, like many will be hostile by human standards. But even the hostile ones teach us how planets work, how atmospheres move, how chemistry changes, and how stars sculpt nearby worlds. What is known is that the galaxy contains an enormous variety of planets. What remains uncertain is how common each kind is, and how many quiet temperate worlds are hidden among them. The memorable lesson is this: Earth is not the template for all planets. It is one outcome among many. And somewhere in that diversity, the next strange world is waiting to change the rules again.